Hello. In this lecture we will discuss the components of IKE gateways. IKE gateways have three databases that work together to make IPsec work. They are the Security Policy Database, the Security Association Database, and the Peer Authorization Database. The Security Policy Database is basically a list of what will be encrypted. In the world of Cisco, it's a crypto map. The crypto map has access lists that determines what traffic is going to get encrypted. The Security Policy Database defines that if network A tries to communicate to network B, then encrypt the traffic, then it's going to check and see if there is a security association that is already in place. It will check the second database, which is the Security Association Database. That is a database that keeps a list of all the security associations that are currently in session. If there is no security association in session, the IKE gateway is going to check the Peer Authorization Database. The Peer Authorization Database contains information about the peer that needs to be contacted to establish the IPsec session. So let's see how the traffic gets handled by the IKE gateway. So imagine a packet coming into the firewall, the IKE gateway. The gateway would check to see if the traffic is going to get forwarded out an interface that has a crypto map or a policy, an IPsec policy. It is going to check that policy to see if the traffic matches a source and destination pair in the list of network pairs requiring encryption. So, that's referred to as a traffic selector. If there's no match, then the firewall would forward normally. If there is a match, the firewall is going to check the Security Association Database to determine if there is already a security association with the remote peer. If there is no security association, the firewall is going to trigger an IKE session running through Phase 1 and Phase 2. To achieve this goal, it will check the Peer Authorization Database to determine the peer information. The Peer Authorization Database contains information about the peer IP address, what type of authentication is used, as well as what encryption and hashing should be negotiated. And then it's going to establish the IKE session with that remote firewall. So that's if there's no entry. What if there is an entry? In that case, the firewall is going to find that security association in the Security Association Database. It will then determine what encryption and hashing is getting used by this session. It will apply the encryption, encrypt the packet, hash it, and then send it on to the destination peer. What about the incoming packets? For incoming traffic, we discussed previously the Security Parameter Index in the IPsec Packets Phase 2. Quick Mode creates the inbound SPI. The source-destination pair that is in the encryption database are assigned an inbound SPI on the firewall. When a packet comes in, this packet is going to have the Security Parameter Index attached to it. That Security Parameter Index will determine what security encryption and hashing to use to process the packet. And based on this information, the IKE gateway is going to apply decryption and validate the hash. It will then forward the packet to the inside network, to the intended host, or the intended inside network that should receive this traffic. If there is no SPI matching this SPI in its Security Association Database, it will discard the traffic. The reason why is that SPI has no matching entries. There is nothing else it can do with this packet. Well, let's see here a packet capture example. So, if we look at an ASP packet, we see that the ASP packet gets received by the firewall. It's mostly encrypted. The only field that the firewall can read is the SPI field. So, this is the field that gets matched against in the Security Association Database to see if there is a valid IKE session. Based on that Security Association check, the IKE gateway is going to run through the decryption and hashing. It will apply the specified decryption and hashing, and then it will forward the packet. We will discuss more in the next lecture.